Hello, hi, namaste. This is Surabhi, your master teacher of chemistry at Vedantu. Welcome to the session, everyone. Hello. Hi, how are you? I'm good, ji. Hi, Sanvi. Hey, Sudarshan. Hi, Hari. Hey, Srilata. Hi, Suchi. Hey, Tirupati. Hi, Sanju. Hey, Shine. It's Shiny or Shine? That's such a sweet name. Hi, Mansa. Hi, Vidhi. कैसे हो? I'm good. How are you? अच्छा, you're a new student. Yes. So we'll have a separate session on that too. Don't worry. Acha, it's Shine, right? It's Shine. That's okay. Completely fine. So shuru kare. Yes, everyone. Study of compounds, ammonia. So we'll learn everything about ammonia, and then last में there will be a Menti session. ठीक है? Yes. High five. Yes, here it is. Ready? Awesome. Okay. Yeah. चलो then शुरू करते हैं. So before that, the Pro Subscription one. So you already know what it is, but where will you get the link? You will get it in the description as well as in the pinned comment, or you can go to vdnt.in/ytpro. So why? If you want to attend unlimited live classes with lots of fun and high-level quizzes where you can compete with the students throughout the world, interactive replays that also includes the quizzes and leaderboards. You will get the handwritten notes, and assignments will be shared with you after every session. Tests will be conducted regularly. You will get the report also. You need to get this. Okay. Chalo. So if you use the coupon code SURPRO, you will be getting additional 20% discount. Single bond is followed. Okay. So today's session we will study about compounds, ammonia. So what do you know about ammonia, people? What do you know about ammonia? Physical properties, chemical properties, कुछ भी. NH3, okay, ammonia is NH3, very good. Ammonia is basic in nature, it's a base, very good. NH3 only, it's basic, okay. Acha, it has a pungent smell, huh? Okay. Colorless gas. Okay. So, chalo, let's go. So, molecular formula of ammonia is NH3. See, ammonium and ammonia are different. Okay, ammonium is an ion, whereas ammonia is a molecule. Okay, it's basically a covalent compound. Its molecular mass is 17 because nitrogen 14 plus hydrogen 3. So, 17 bonding hai, covalent bond where the nitrogen and hydrogen are sharing electrons. Okay. Bitter taste. When have you tasted ammonia? Huh? Because it's a base. Yes. So this is how the structure looks like. Okay? So there is this lone pair of electron. So basically this is how it looks like. Same, but there will be a lone pair of electrons. So to decrease that repulsion, so the bondings, the hydrogen have placed themselves very far from each other. Okay? Okay? So occurrence in free state, it's like you will find ammonia in free state, that is in a small amount in the air and in the traces in natural water, but generally you will find it in the combined state, ammonium chloride, ammonium sulfate. Okay? Hi, I'm good, thank you. Okay. So ammonia and ammonium compounds are highly soluble in water, so they do not occur as minerals. So note the pungent smell which one encounters near a decaying heap of organic matter or a toilet it's because of the ammonia. So what happens? So there will be formation of urea, right? Basically in the toilet and all that. So there will be decomposition of urea by the bacteria. So then you will get ammonia gas will be liberated. So that pungent smell near all those things is because of the formation of ammonia gas. So this is urea, the first organic compound. You remember, right? So it's basically its structure is NH2 C double bond O NH2. Okay, so there will be bacterial decomposition and you will get ammonia, water and carbon dioxide. Yeah, you know, if actually a fainted person, so it can wake up a person who has been fainted, because you know, if you smell it, that's how strong it is. Hi Poonam. Hi Nakshata. Okay. So forms of ammonia, so you will find it in gaseous form, liquid ammonia and liquor ammonia. So basically liquor ammonia is, it will have almost 33% ammonia. And the laboratory, see, even in laboratory for the qualitative analysis and all that, so we will have stored bottle of ammonia which we use in laboratories. That is what is laboratory bench reagent. So we will use it as reagent in the qualitative analysis. That is what is present in this compound. There we use ammonia as a reagent. So these are the 4 forms in which you will find ammonia. So liquid ammonia is liquefied ammonia and available in cylinders. See, what you are doing is you are just condensing it, right? By applying pressure, we are liquefying it, and usually you will find it in cylinders. How we have LPG in the same way. Okay, that is liquid ammonia. And the second one is the liquor ammonium photos. So basically it is a saturated solution of ammonia and water. So you will almost, the concentration will be 33 to 35% of ammonia in water. Okay? Hi Suhita. So it is called 880 ammonia because its relative density is almost 880, and it has to be stored tightly in the stoppered bottle. Stoppered bottles means you will have these things, no? The stoppers, so they have to be placed, they have to be stored in a bottle using the stopper, and it has to be stored in a cold place. It's a relative density. Okay. So the laboratory reagent, as I told you, it is diluted solution of liquor ammonia. So that will be concentrated, right? There will be small amount of water, but here as we are using it for reactions, very basic reactions, so we will take the diluted solution of liquor ammonia as a reagent for various reactions. Why? So general methods of preparation, ammonia gas can be prepared by warming an ammonium salt with caustic alkali, that is maybe slake lime or caustic soda or caustic potash. So here you can take either CaOH twice or KOH or NaOH. So if you take any ammonium salt, so when you just heat it, warm it up with any of these salts, you will end up getting ammonia. Can you guess the other products? Can you guess the other products? Can you guess the other products? Come on fast. See, limestone is basically calcium carbonate. Slake lime is CaOH twice. Salt and water. You will get it. Salt and water. Pakka. H2O will be there, because you are seeing OH twice everywhere. Very good. So ammonium chloride plus slake lime, you will get calcium chloride, salt, water along with the liberation of ammonia gas. Very good. Come on, give me a high five. Good job, people. So NH4Cl, CaOH twice. So what we are doing is, so if you look at the ratio, we are taking the alkali is in a greater volume. Why? Because we all know NH4Cl is sublimable, है ना? So it might just evaporate. So to make sure that there is enough alkali and the ammonium chloride, so we will take it in the ratio of 2:3 by weight. So this is how the setup looks like. So the round bottom flask must be in the slanted position, so that when the water is formed, the hot water should not get into the flask, it might break it. So that is the reason we will always keep it in the slanted position. And here you have NH4Cl, CaOH twice. If you just warm it, so ammonia gas will be liberated, and this is, the mouth is downwards. Okay, and here you can see calcium oxide, which is a drying agent, because we don't want anything else, we don't want water, right? So anhydrous calcium oxide is a very good drying agent, so it absorbs all the moisture, so only ammonia gas will be collected here. So this is the reaction. Okay. So drying of ammonia gas, as I told you, in order to get dry ammonia, so we will pass the gas through calcium oxide, which absorbs, and if there is any moisture content in the ammonia gas, so it will be absorbed by the anhydrous calcium oxide, and only you will get the dry ammonia. So there are other drying agents too, right, like sulfuric acid or calcium chloride. Why don't we use it? So as they do react with ammonia, so they can react with ammonia, but we want the CaO not to react with ammonia, just to absorb the moisture. So that is the reason. So preferably we choose calcium oxide as a drying agent and not other compounds. Yes, CaO is quicklime. So ammonia gas is collected in inverted gas jar by downward displacement. Why? Because it is lighter than air. So when ammonia is passed, so it just displaces, it just pushes out the air, so that ammonia will be collected at the bottom. Okay. So how ammonia is collected? This is an important question. How ammonia gas is collected? It is collected by the downward displacement of air. Why? So the vapor density of ammonia is 8.5, whereas air is 14.4. So it is, as it is lighter than air, so obviously, so it will be collected by the downward displacement of air or upward displacement of ammonia. Yes. And but see, there are different ways. Okay, so you can either collect it over water or air. So here we cannot collect it over water because this compound ammonia is highly soluble in water, so it just dissolves. Again you have to separate it, so that is the reason it will be never collected over water, but by the downward displacement of air. See, for example, what I told you was, see, air is lighter. Okay, so what happens? Ammonia will be collected over the air as it is lighter than air. You will get the notes. Don't worry. Hi Nitin, good evening. So ratio of reactants, why is it taken in the ratio 2:3? So higher ratio by weight of alkali, because so it has to counteract the loss of NH4Cl by sublimation. As I told you, it is a sublimable substance, right? When you are heating it, obviously it might evaporate. So to make sure that there is enough amount of ammonium chloride and alkali for the reaction, so we will take it in the ratio 2:3. So calcium hydroxide, why are we using? So we could have used KOH, NaOH. Why are we using it? Because it is cheap. So industrial process may, it's not like we will take 3 grams or 2 grams, right? So calcium hydroxide is used as it is cheap and it is not deliquescent. That means the others, they are soluble, they just dissolve. Okay, but this is not like that. So you will find it in the solid form. That is the reason we use calcium hydroxide and not the other alkalis. Though all ammonium salts, so it all gives. So whenever you take any ammonium salt, so when it is heated with an alkali, you will get ammonia, but we are not using ammonium nitrate because you know ammonium nitrate is an explosive. So we have done a video on it, right? Ammonium nitrate, you remember the explosion? Yes. Okay. So from metal nitrides also you can prepare by, you know, when you react water and metal nitride, you will get ammonia, but this reaction is expensive, so usually people does not, you know, follow this reaction as it is expensive. So see, no, it's not about being cheap and all that. It's not about looking for the cheap agents. Of course it has to be safe. We have to you know, make sure that every reagent, every reaction, it should not be explosive, and you know, it should be easily collectible and all that, right? So that is one of the criteria. That's it. Cow. So today there are no dogs, there are only cows. Huh? My school friends are here. Who? Hi Chinmaya. Hi Kanishka. So this is what, so we have this thistle funnel and the magnesium nitrate, any metal nitride plus water. So using this, only small amount of water will be a load, and then this ammonia gas will be collected, and same, okay, it has to be passed through calcium oxide to make sure that it is completely dry, and ammonia gas will be collected here. No, I don't have, but yeah, there are few cows in the neighborhood. See, there are two products will be formed. So magnesium nitrate is Mg3N2 plus water, so you will get ammonia, plus magnesium hydride will also be formed, MgOH. Okay? But what happens here is MgOH twice, but MgOH twice will remain in the flask. Ammonia gas, as it's a gas, it will be through this delivery tube, so it has to pass through the calcium oxide, and the dry ammonia gas will be collected there. No, I don't have any pets. I don't have cats, dogs, cows. Yeah, let me make it clear, that's not mine. Got it? Yes, it gets evolved, and the collection, it is same as that of the first process. Achha. I'm not allowed to have any pet. So aqueous solution, what is aqueous solution? Ammonia gas, when it is dissolved in water, you will get the aqueous solution of ammonia. So how to prepare this, you tell me. Even when we are mixing water also, should there be any process, any rules to be followed, or just mix karo, like how we prepare lime juice? Tell me. NH3 plus H2O, you will get base. Which base? Funnel arrangement. Very good, very good. Who's that? Marvel. Very good. So what happens is there? What happens here is, so ammonia being highly soluble in water, so sometimes there will be back suction of water. That is, water enters the funnel. Okay, we don't want that to happen. So that is the reason the arrangement of the funnel, it should just touch the surface of the water to make sure that the water does not get into the funnel. So I'll tell you, so what is that? So this is how the funnel, right? So inverted funnel, and this will be, so the ammonia gas will be passed. So here, as ammonia gas is highly, very soluble, so what happens, sometimes there will be back suction of water. Water gets into the funnel. We don't want that to happen, right? We want ammonia to get dissolved in this water. So to prevent that, to avoid the back suction, so what happens, you should just keep the funnel in such a way that it should just touch the surface of the water. So for some time there will be back suction, and again because of the change in the pressure, and again it will be back to normal. Hi Yogesh, oh, hi. Same as HCl, yes, same as HCl. See, this is how the setup looks like. So ammonium chloride, calcium hydroxide, you will get ammonia, or just ammonia plus water. So how does it dissolve? To make sure that there is no back suction of water, this is how the setup should be. Okay. And manufacture of ammonia by Haber's process, the industrial method, the reaction which changed so many things. So what is this Haber's process? So it is an industrial method to synthesize ammonia using nitrogen and hydrogen. So now can you tell me, where do you get, from which reactions can you get nitrogen and hydrogen? Tell me. So after the session, if you check the description, you will get the notes. From air, acha, okay. So I'll just keep it a nitrogen, please. Get into the water bottle. What do you mean by air? Which method? Yes, very good. From Bosch process, hydrogen and nitrogen. Liquefaction of air, right? Liquefaction of air. You will get nitrogen gas. Hai na? Yeah. So that you will study later, okay? That's a method to get hydrogen gas. Yeah, that's what. Liquefaction of air, you will get the nitrogen gas. So So now what happens? Nitrogen plus hydrogen is there. It's a reversible reaction. So you all know what is a reversible reaction, right? So nitrogen and hydrogen can combine to give ammonia, whereas ammonia can undergo decomposition to form back nitrogen and hydrogen again. So here in this reaction, the conditions is very important. What are the conditions which we have to follow? So the temperature, pressure, which catalyst are we using, what is the promoter? So that I'll tell you, and then I'll get back to this flow chart. So this reaction is reversible and exothermic. So N2NH3 plus heat energy is also evolved as along with the product. But what happens here is, so here if you take the reaction, if we'll have a look at the reaction, can you balance it, people? Let's see, balance it. Temperature 450 to 500 and the atmospheric pressure like almost 250 atmospheric pressure, and finely grinded iron as a catalyst and promoter, molybdenum. I'm in Bangalore. Yes. Pooja Hegde? Who is Pooja Hegde? N2 plus 3H2, very good, 2NH3. So you see here, you have 4 moles of reactants but only 2 moles of products. Okay, the product of the volume, there will be decrease in the volume because these are all our gases, right? So it is, the ratio is by volume, okay, not weight and all that. So 1:3 volume of nitrogen and hydrogen, and there will be formation of 2 moles of ammonia gas. So to make sure that the reaction has to proceed in the forward direction, so applying pressure is very important. So this is the flow chart. Please, I want all of you to practice it. Okay? So nitrogen and hydrogen gas, first we will compress it, that is around 200 to 250 atmospheric pressure mein. So we will just mix it, and then what happens, it will be sent to the catalytic reactor. There we have iron, finely grinded iron, and then promoter, maybe sometimes you use molybdenum or Al2O3, and then that's where the reaction takes place. So you will have, now in this you will have ammonia, nitrogen and hydrogen, all the 3 products. There will be unreacted nitrogen and hydrogen. So all of the three substances will be sent to the cooling chamber. So where there will be condensation. So what happens, as ammonia the force of attraction is very high because of the formation of hydrogen bonding and all that. So they can be easily condensed, and they are highly soluble in water compared to nitrogen, and nitrogen was sparingly soluble. So using that, so we will condense the ammonia. The unreacted nitrogen and hydrogen will be sent back to the compressor. Okay? Yes. So what is promoter and poison? I'll tell you. So see here, first let me explain it again. Nitrogen and hydrogen gas will be sent to the compressor chamber, where the pressure is almost like 200 to 250 atmospheric pressure. So where there will be mixing of the nitrogen and hydrogen. So because when the pressure increases, obviously the atoms will be brought together. They will start colliding, right? That's when the reaction happens. So the atoms must be colliding to each other, and then it will be sent to the catalytic reactor, where there is finely grinded iron and the molybdenum as a promoter, or you can take Al2O3. So what are the roles of the catalyst, promoter and all that, I'll explain. And then it will be sent to the cooling chamber or condensation chamber, so where ammonia will be condensed or cooled, but the unreacted nitrogen and hydrogen will be sent back to the compression chamber for the formation of ammonia again. Now here, what are the conditions? So you already told me. So what happens is, here the temperature must be 450 to 500 degree. But we just told you it's an exothermic reaction, then why should we still heat it? 500 degrees Celsius is not a very low temperature, right? So here, as it's an exothermic reaction, it was okay even if this reaction was done in low temperature. But only when there is increase in temperature, because this nitrogen and hydrogen, they are like, this reaction is not spontaneous, okay, because it's a reversible reaction, right? To make sure that the reaction is moving in the forward direction, so it is very necessary to heat it. So the optimum temperature is 450 to 500 degrees Celsius, and the pressure is about 200 atmospheric pressure. So catalyst, finely divided iron, and the promoter, molybdenum or Al2O3. Now what is the role of catalyst? See, so for example here, I'll tell you, okay, Divija. So Divija, like, you need to go to your grandmother's place or come over to my place. So almost the distance is 10 kilometer. Okay, and I'll tell the same thing to Divakar too. Is it Divakar or Tarika? But Divija, what she thinks, oh my god, should I go? It's very far, right? Why should I travel 10 kilometer? Okay, 10 kilometers is such a long distance. But Divakar, he knows the shortcut which takes him like 5 to 10 minutes. That's all. Which is almost like 5 kilometers. So obviously he is willing to travel because it's a short distance, whereas Divija is not, because it's a very long distance. So what catalyst does it? So here, this is the energy level, okay? So it has to, for the formation of products, these reactants has to make sure that this energy, it has to cross this energy, then only products will be formed. But this catalyst, it will make it easy for the reactants. It is just reducing that energy level, okay, the threshold energy. So obviously most of the reactants will be converted into products, right? So this is the, it's Tarika. So it increases the rate of reactions, but not only forward, both forward and backward, both, okay? And the promoter, what it does, it ensures that catalyst is working fine. So it increases the efficiency of a catalyst. So these are the favorable conditions. And one more important thing is the nitrogen and hydrogen which you are taking must be free of impurities. No impurities allowed. So what happens if there are any impurities like hydrogen sulfide or carbon monoxide, carbon dioxide? So that will poison the catalyst, and the catalyst does not work, or there will be some other kind of reaction. So then what is the use? So for this reaction, especially for few reactions, the role of catalyst is very, very important. So make sure that the nitrogen and hydrogen are free of impurities. Okay? Okay. As I told you, so it just brings down that energy, the threshold energy. Okay? Yes, okay. So what enzyme does it, right? 5 p.m. every day. Hi Sejal. Got it, no? The favorable conditions, this is important. They might ask you why nitrogen and hydrogen must be free of impurities. What happens if there is an impurity? What is the role of promoter? So you should know all these points. Clear, people? Yes or no? Thank you, Shreya. That's so sweet. Yep. Okay. Moving ahead. So obviously there will be nitrogen and hydrogen also. We'll just send it back to the compressor. So how to collect it? How to recover the formed ammonia? So liquefaction. As I told you, ammonia compared to nitrogen and hydrogen, it is easily liquefiable, and its solubility is also very much high compared to nitrogen and hydrogen. So promoter, as I told you, it enhances the role of catalyst. It makes sure that the catalyst is working fine. Yes. Okay. So since the reaction is exothermic, so the first point I told you, heat energy will be evolved along with the products. So that heat evolved will maintain the temperature. Okay, but at the beginning of the reaction, you need to make sure that the temperature is around 450 to 500 degrees Celsius. So external heating is therefore not required, but the reactants must be initially heated. What should be the temperature? 450 to 500 degrees Celsius. I'm good, thank you. It's not about easy or difficult. So in ICSE, we'll just go into that. It's very deep, we'll learn about everything. Very good. So why? So even though the reaction is exothermic, so why to heat it to 450 and 500 degrees Celsius? Because if the temperature is low, then the atoms, we know, right, with the increase in temperature, the kinetic energy of atoms also increases. So if there is low temperature, atoms will be like, jana hai ya nahi, jana hai ya nahi. But if there is high temperature, they will run and collide into each other, and there will be formation of products. Okay, like ours. Yes, it is a reversible process. Yes. So 4 volumes, as I told you, there will be decrease in the volume of the products, and the optimum pressure is like 250 atmospheric pressure is used. Of course, Angel, all the very best. Pakka wala clear. हाँ मेंटी है जी, but not now. So catalyst and promoter. So what is the use? What is the role of catalyst? The speed of the reaction, the rate of the reaction can be improved by using a catalyst. So why are we using the finely divided iron? Because there will be higher surface for the reaction to take place, right? So what happens? How do you get the iron? Is by the reduction of iron oxide. And promoter is used to increase the efficiency of the catalyst. So either you can use molybdenum or Al2O3, that is aluminium oxide. Hey, congratulations Neil. Once you are done, just send me the question paper. Who's your favorite teacher at Vedantu? I like all of them. They're all different, but they're all very good. Y, P and D. Start now. So what are the physical properties of ammonia? It is colorless, strong, pungent, choking smell, slightly bitter as it is a base. Okay? This is how our face goes. Oh, that is the most difficult part, of working in the lab, because the smell. Oh, you also have it. All the very best people, all the very best. Choose one. No, I can't. All of the above will be my answer. So physiological action, that is what happens if you come in contact with the ammonia gas. It is non-poisonous, but if you inhale it for a long time, it brings tears to eyes. It's kind of like itchy feeling. That is it. Powerful heart stimulant, and it may cause death if you inhale it in large quantities. Okay, large quantities. But in the laboratories, we will just take 2 drops of ammonia, then you will be fine. It's okay. I guess yes. So if I have to choose one between ammonia and hydrogen sulfide smell, yes, it is ammonia. Yes. Oh, hydrogen sulfide, it smells so bad. Why, Anjali? You like hydrogen sulfide smell? Don't tell me. I have done a separate video on ammonium nitrate. If you want, you can watch. Yes. Okay. So its density, vapor density is 8.5. It is lighter than air, and its nature, it is alkaline. So it can be easily liquefied by compressing at 6 atmospheric pressure. That's it. Yes, Shreya, we are planning to, dear. It's just that, I'm at home, right? So it's kind of difficult. You have such a good friend, Sanju. If it was my friend, no, they will be like, come, no, smell. It smells so good. That's what I would have done too. Well, why should you suffer alone, right? When you have friends. So its boiling point is minus 33.5 degrees Celsius, obviously because it's a gas, and it freezes, or the solid ammonia melts at minus 77.7 degrees Celsius. Chemistry Olympiad, yes. Done. Hoga, see. Spandan is like, you tell me when is the menti, I'll come back then. Upcoming video tomorrow. So solubility is highly soluble in water. 1 volume of water dissolves about 702 volumes of ammonia at 20 degrees Celsius and 1 atmospheric pressure. So Haber's process is very, very important. So please pay attention. And what are the chemical properties of ammonia? Thermal decomposition. What is thermal decomposition? Come on, come on. What is thermal decomposition? Everyone knows. For all. Come on. Thermal decomposition क्या है? All the very best, everyone. Come on, give me a high five. No, it's a fist bump. You will do well. All the best. Decomposition in presence of heat. Acha, what is decomposition, ji? What is decomposition? Thank you, Sudarshan. Aha. Decomposition due to heat. Nice, no? Thermal matlab heat. Decomposition. Nice, nice, nice. Breaking. Okay. So ammonia gas, it dissociates into nitrogen and hydrogen at high temperature and by electric sparks. Is it Hindi or This is supposed to be or no? So NH3 in the presence of heat energy or in the when electricity is passed, so it will be decomposed into nitrogen and hydrogen. Again, it's a reversible reaction. So its basic properties: dry ammonia is a covalent molecule, so obviously it is neutral even in liquid form. In its aqua solution, it's a weak base. So why is it basic in nature? Because of the presence of lone pair of electrons, and it can accept the proton and can form ammonium ion. So that is the reason it's a weak base. Okay? Yes. So this is the structure of ammonia. So you can see the lone pair, right, which can be donated. So that is the reason it is basic in nature. So an aqueous solution of ammonia, NH4OH, is a weak base. Why is it a weak base? Because it undergoes partial dissociation and it associates partially to give OH minus ion. Okay, so NH4OH, NH4 plus OH minus. Okay. So ammonium hydroxide can give OH minus ion. But why ammonia is also a base? That is because of the formation of, as it has lone pair of electron. Okay? Very good. Hi Palak. So the alkaline behavior is because of the presence of formation of hydroxyl ion OH minus. See, NH3 plus water, so when it is dissolved in water, then ammonium hydroxide will be formed. Ammonium hydroxide will undergo dissociation to give us hydroxyl ion. So this is the reason it is basic in nature or alkaline in nature. But ammonia, just ammonia, is also basic in nature because of the presence of lone pair of electron. So if it can donate the electrons, yes. So what are the, how does it, react with the indicators, action on indicators? Litmus, obviously red to blue, as it's a base, red to blue. And what happens with phenolphthalein? Phenolphthalein, what happens? Methyl orange, red to blue, okay. So methyl orange, it's basically orange in color. So what will be the change? Phenolphthalein is colorless to pink. Very good, colorless to pink. This one? Pink. Yellow, right? Okay, very good. This is something everyone knows, no? Indicators, matlab, yes, we are perfecto in that. So phenolphthalein is colorless to pink as it is basic in nature. So reaction with acids. So as ammonia is basic in nature, so as it's a weak base, it accepts protons, right? So there are different definitions for acid and base, So a compound which accepts proton is also known as a base. So it accepts proton to form ammonium ions, and it reacts with acids to form ammonium salts. So obviously you will have ammonia plus any acid, you will get ammonium salts. But the same product will be formed when it is made to react with ammonium hydroxide as well. Ammonium hydroxide plus HCl, what will be the product? Same product, NH4Cl, plus there will be formation of water. So this is the only difference. NH3 plus HCl, you will get ammonium chloride, white solid. NH3 plus HNO3, you will get ammonium nitrate. So when you dissolve ammonia in water, you will get the same salt along with the formation of water. So ammonium chloride is a good example when two colorless gas is reactive. That is, you have HCl, you have ammonia. So bring it together, you will get a white solid. That is ammonium chloride. When two gases react together, you will get a solid compound. So this is a very good example. You want to see this? See here. So in one you have any acid, and in other flask you have ammonia. Okay? Hi. See, ammonium nitrate, ammonium chloride, they both show thermal dissociation, but ammonium nitrate is an explosive, so you have to be very, very careful. Okay, but they both undergo the thermal decomposition to give us ammonia plus hydrogen chloride and then N2O plus water. Any CBSE student, of course there are. So how does it react with metal salts? So ammonium hydroxide, this is the reason why we use it in the qualitative analysis, okay? So ammonium hydroxide, it reacts with the soluble salts of metals, for example, FeOH twice or AlOH thrice. So they react with the soluble salts of metals to give insoluble precipitate of their respective metallic hydroxide. Of course, sodium and potassium, they dissolve, right? So but these iron or aluminium ka hydroxides, the metal hydroxides, they form when it is made to react with ammonium hydroxide plus any metal salt. So there will be a double displacement reaction, and you will end up getting the hydroxides of those metals which are basically insoluble. And they will have different colors, okay? So this helps us to identify which metallic or a cation or a basic radical is present in that particular salt. Hi Lokesh. See, the precipitate formed by the different metallic hydroxides, they have different color. So this is the reason in the qualitative analysis of the cation will use ammonium hydroxide as a reagent. Okay? See, metal basic oxides, if we are talking about the oxides, of course they are basic in nature. Carbonates, they are basic in nature, but there are different salts too, right, based on from which acid and base they have been derived. So we can't just generalize that all the metallic salts are basic in nature. Okay. So reaction with oxygen. See, ammonia, oxygen together, it's really not a good reaction. Firstly, ammonia is not a supporter of combustion, nor it extinguishes. It extinguishes a burning splinter, but it does not burn in air. But in the presence of oxygen, only oxygen, then it produces the yellowish flame. So it does not burn in air, but it does kind of burns in oxygen. It is not a supporter of combustion. It actually acts as an extinguisher. Yes. So it burns in oxygen with the yellowish flame. Hanji, you can see here. See? Can you all see it? Yes? Hello. So NH3 plus 3O2, there will be formation of nitrogen gas and water. So it burns in oxygen with yellowish green flame. But as I told you, mixture of ammonia and oxygen, they are explosive in nature and can be dangerous, or you have to be very, very, very difficult when we are conducting this experiment. So 4NH3 plus 3O2, you will get nitrogen and water. This is the reaction between ammonia and oxygen. Okay? So it burns with yellowish flame. Okay. Yes, nitric acid will also be done. Don't worry. So catalytic oxidation of ammonia. So what is catalytic oxidation? So we all know oxidation is gain of oxygen or loss of electrons, loss of hydrogen. So in the presence of platinum at 800 degrees Celsius, so ammonia, it reacts with oxygen to give nitric oxide and water vapor. So here basically ammonia is losing hydrogen. Okay, you will get nitric oxide plus water vapor, and again it will react plus oxygen, it will react again with oxygen, you will get nitrogen dioxide. So this is the reaction. So ammonia in the presence of platinum as a catalyst at 800 degrees Celsius, so it gets reduced to nitric oxide and water vapor. That nitric oxide, if there is excess of oxygen there, it will again combine with oxygen to give us nitrogen dioxide. This one. Okay, see what happens is, you will take ammonia plus oxygen in the presence of platinum. You need to heat it to 800 degrees Celsius. Then what happens, there will be oxidation of ammonia to nitric oxide. Okay, and this is getting reduced. So there will be formation of water vapors and nitric oxide will be formed. So this is the reaction. So don't worry, you will get the notes. Don't worry about it. Okay, समझ आया? That's nice. हाँ, समझ आएगा तो मजा आएगा, है ना? So how will it react with carbon dioxide? Can you tell me the product, people? Let's see who will guess it right. Ammonia plus carbon dioxide. What happens? Acha, I didn't see anyone. -3 to +2. Okay. Are we talking about reduction? Urea is formed. Very good. क्या बात है जी? So NH3 plus CO2, you will get NH3 twice CO, right? So this reaction is important because urea is a fertilizer, right? Hi Sachin. So at 150 degrees Celsius, and at 150 atmospheric pressure, so ammonia will react with carbon dioxide to form urea, which is a very, very important product because it is used as a fertilizer. And this is the reaction. I have already written it. So 2NH3 plus CO2, so you will get NH2CO, NH2 plus water. So this is the reaction. Let me just write it again. So this is how it looks like. Okay, NH3 plus CO2, you will get urea along with the formation of water. So ammonia as a reducing agent. Now ammonia, it was oxidized, right? So if it has to act as a reducing agent, obviously it has to undergo oxidation and has to reduce the other. So here we have two different conditions. When you take ammonia as an excess, as an excess reactant, so what happens is the products formed will be different. Okay? Yes, CONH2 twice is right. So NH3 plus Cl2. So here Cl2, chlorine is getting reduced to HCl. You can see here, right? Cl2, there is no hydrogen here, but on the right side you have hydrogen, and ammonia is getting oxidized. So because there is removal of hydrogen. So ammonia plus chlorine. So you will get nitrogen plus HCl. But what is the condition? when ammonia is in excess. So there is 6NH3 plus 6HCl. So what happens? It will combine with the formed hydrogen chloride to give us ammonium chloride. Ammonium chloride. Okay. So 8NH3 plus 3Cl2 N2 plus 6NH4Cl will be the reaction. Yes, got it, people? Yes or no? So many chemicals. See, there are two different conditions. Okay? When you have taken ammonia in excess, so if there was no excess of ammonia and all that, so the reaction would have been very simple. So NH3 plus Cl2, you will get nitrogen plus HCl. But here what is happening, as we have taken ammonia in excess, so that ammonia which is present in excess will react with the formed hydrogen chloride to give us ammonium chloride. So these reactions are something which you have to practice. Okay? Yes. Now when ammonia is in excess is done, right? So the yellow green color of chlorine disappears because here we have chlorine, right? The reaction is basically NH3 plus Cl2. This is the observation which is visible to our eyes, because what is happening inside we don't know. So basically chlorine, it just disappears and there will be formation of ammonium chloride, that is white fumes of ammonium chloride will be formed when there is reduction of chlorine to HCl. Hi Suchitra, I'm good dear, how are you? So many equations, huh? Now the other one, there is two reactants, right? Ammonia and chlorine. Now we are taking chlorine in excess. Can you guess products? What happens? What might be the product? So when chlorine is in excess, so NH3 plus Cl2, what will you get? N2 plus HCl, but you have taken chlorine in excess. You're always confused. NCl3 and HCl. Acha. So HCl and the yellow colored highly explosive liquid nitrogen trichloride. Why is it nitrogen? One atom of nitrogen and there are 3 chlorine atoms, right? So nitrogen trichloride will be formed because nitrogen ka valency is -3 and chlorine is -1. So this is basically covalent form and every nitrogen atom needs 3 bonds. So nitrogen, so it will combine with 3 chlorine atoms to form nitrogen trichloride. याद है? अच्छा. NCl3, not NH3Cl. NCl3, nitrogen trichloride it is. Okay? Tri. Nitrogen chloride is wrong. Nitrogen trichloride it is. Yes, it's an explosive and it's not very common, right? I guess this is the first time you are hearing that compound. So these reactions, what it shows that, so ammonia is acting as a reducing agent, right? Because it is reducing chlorine to hydrogen chloride, and it also shows that the chlorine has a greater affinity for hydrogen. So it is easily formed hydrogen chloride, chlorine to hydrogen chloride. So these reactions, this reaction that is, so when you take ammonia in excess and chlorine in excess, so what are the observations? So which we got is that chlorine has a great affinity for hydrogen and ammonia is a reducing agent. Why jacket today? Because it is very cold. Please tell us tricks to remember chemical equations. See, not for all the things I don't think you will get tricks, and when it comes to equations, no. So rather than trying to come up with new tricks, if you just sit and practice, so it will be very easy actually. Hi Suneha, I'm good. Now next is ammonia as a reducing agent, reduction of metallic oxides. So ammonia, it reduces the, what is happening? So ammonia reduces heated metallic oxides to give metals, water vapor and nitrogen. So for example, here I have CuO, which is a black solid, we know, right? Brown to black when it is oxidized. So CuO, when it is reduced, you will get the reddish brown solid. So here ammonia is acting as a reducing agent. Why? Because it is helping in the reduction of CuO2 copper. So these are the three products formed: ammonia plus metallic oxide. So it helps in the reduction of metallic oxide to the respective metal. So what are the three products formed? Metal, water and nitrogen gas. No, it is cold. So ammonia as a reducing agent. Okay. So if you take lead oxide will be reduced to lead. So PbO to Pb in the presence of ammonia, which is acting as a reducing agent. I don't like cold, so I like it, if it is very warm. You're done with the reactions, right? You're like, it's not ending. So all ammonium salts, they generally produced ammonia gas when alkali, like sodium hydroxide. That is, you have some ammonium chloride plus NaOH. So what will you get? You will get ammonia gas. Ammonia gas will be liberated. So that is a test. So whenever you take any ammonium salt, you want to check. See, in the qualitative analysis, they will give you different salts. Okay. So you need to identify which cation and which anion is present. So if I want to know whether there is ammonium ion is present or not in that particular compound, so if you add an alkali to it, or like sodium hydroxide, potassium hydroxide, if you can smell ammonia, okay, that means ammonium ion cation is definitely present in that salt. Okay. So because it has sharp characteristic odor, so we have spoken about it, and it turns the moist red litmus blue. If you are taking gas, so obviously the litmus paper must be wet, right? Otherwise there won't be any change. So as it is basic in nature, it turns the red litmus blue. What happened, G? And phenolphthalein solution into pink color, turmeric paper brown. What happened? So on the other test is, so ammonia gas, it can be easily recognized. So what happens, you have ammonia, so you just dip the glass tube into the HCl and bring it near the mouth of the test tube. Okay? If you can see the white fumes, because there will be formation of NH3 plus HCl, there will be formation of NH4Cl, which is basically white fumes. So the white fumes which you can see here is ammonium chloride. So this is a test which you will be doing it in the next year. So you will know. So this is also a test to identify whether there is ammonia present in the compound or not. Hi Meet. It's not mine, but only I teach. It's becoming, okay, we are done, we are almost there. Okay, ho gaya. So at first it forms, so when you will take ammonia and when you dissolve it in copper sulfate, okay, so first it forms the bluish precipitate, and then on excess addition of ammonia solution, it just dissolves. So at first the blue precipitate with copper sulfate solution, can you see here the precipitate? Oh, it looks so beautiful, see, and then it just dissolves to form a deep blue colored solution, and on excess of addition of ammonia solution. See, it's basically 80 plus 20 it is. 80 and 20 is for assignments, right? And you will get only 1 hour 30 minutes, no? है ना? हाँ. I know, right? The color is so beautiful. So ammonia gas, it just gives, see, ammonia gas, how it reacts, and the ammonium, the solution, how it reacts is different. So ammonia gas, it just gives brown fumes when it is made to react with Nessler's solution. So again, anyone, so this will be our homework. I want you to tell me what exactly is Nessler's solution. Don't tell me now. Okay. So I want you to just let me know in the comment section what is Nessler's reagent. It is also called as Nessler's solution. So I'll tell you there are 3 different ion elements present in that compound. Achha, when I wrote, we used to get only 1 hour 30 minutes. Yes, 1 hour 30 minutes plus 15 minutes to go through the question paper. So, and a slightly alkaline solution of potassium mercuric iodide. That I almost gave away the answer. Yes, I'll check. What happened? So study of compounds of ammonia is done today. In the next session, we'll come up with another compound. I know what it is, nitric acid, right? So we'll get done. So your homework is, I want you to let me know in the comment section what exactly is Nessler's reagent. Yes. हाँ. स्पंदन जी, कमेंट में लिख दो. After this chapter, Shreya, so we are done with electrolysis and the study of compounds. We are left with another 2 compounds and then we'll start with metallurgy. Okay? Yes. Now we'll start the menti. Just give me a minute. हाँ जी menti होगा. Don't worry. You're all like menti. Okay. So can you all see what happened? Ha. So everyone go to www.menti.com and use the code 474111171. Why didn't you start earlier, Archit? Huh? What is Menti? It's a quiz. Is ICSE harder than CBSE? I don't think so. It's not. But you will be learning something extra which you won't in CBSE. Come on, join now people. Go to www.menti.com and use the code 4741171. Yes, I'll wait. ठीक है? हाँ. So till then, let me just promote our channel. Do not forget to subscribe and like the session. Share this with your friends also, and let me know in the comment section what exactly is Nessler's reagent, and if you have any doubts related to this topic. So give lots of love. Thank you. What's the code? 4741171 it is. I see a lot of armies, in the channel. Praying all that is something I don't do, but I really wish you will do well. Okay, all the very best. Come on. Did you join? Why? One hour correctly. Yeah, ICSE it takes a lot of time. Electrolysis का मेंटी होगा. Yes, shall I start? Shall I? Yes. Look, someone is saying प्रे से कुछ नहीं होता है, मेहनत करनी पड़ती है. वही ना, इंकी पिंकी पॉन्की. हाँ, doubt and menti दोनों होगा. Don't worry. So you can just let me know what are your doubts related to this chapter. Hi Anil. Okay then, I'll be starting. It's already 6. Hi ma'am, I know you. Hi Harsh. Come on fast. Shall I start? Yes. Why I see 22 students here and there were almost 30 students. They are not here or here. Where did you go? Acha, believe you. Okay, then I'll be starting. All the very best. Ammonia can be dried by. Anhydrous calcium chloride, calcium oxide, concentrated sulfuric acid, none of the above. Ammonia can be dried by. Come on, fast. Last 25 seconds. I told you, why can't we use anhydrous calcium chloride and sulfuric acid, right? Why? See, ammonia plus metal salts, you will get different product. Acid plus base, you will get different products. We don't want our ammonia to react with a drying agent, right? है ना? So we use calcium oxide as a drying agent. ठीक है? Very good. So on the leaderboard we have okay, Aditi, Spandan, Nestler's reagent. Who is that? Shreya, Shruti, Sanju loves chemistry is back. That's sweet. Gunjan, Sanvi, Shreya in Keeping You Bonky. Prince, ICSE, high five. High five. That's nice. That's you? Srilata? Okay. Ammonia reacts with carbon dioxide to form. Ammonia reacts with carbon dioxide to form nitric acid, ammonium carbonate, ammonium cyanide, urea. Very good, very good. Hi Gaurav. Think and answer. Ammonia reacts with carbon dioxide to form what? Acha. That's you, Sudarshan. Yes, last 5 seconds. Come on. So you were like ammonia plus carbon dioxide, ammonium carbonate. Wow. Urea will be formed, right? CONH2 twice. Urea will be formed. Ammonia plus carbon dioxide, you will get urea. Hi Irshad. So on the leaderboard we have Sudarshan, Nestler's reagent, Shreya, Spandan, Shruti, Aditi, Shreya, Sanvi, Suchi, Riya, Anjali. Very good. Yes. So question number 3. On your screen. Which is not the physical property of ammonia. Ammonia is heavier than air. Ammonia causes tears in the eyes. Ammonia has a characteristic pungent smell. Ammonia is a colorless gas. Come on, you can't get this wrong, huh? Come on. सच में नहीं पता? ठीक है, that's okay. You just join now, no hurry. Huh? Yay! Of course, it has a characteristic pungent smell. Who chose that? Everyone knows it. So ammonia, it causes, it brings tears in the eyes. Not because it is very good, not because you are happy or sad. That's how it is. And ammonia is heavier than air. Is wrong. It is lighter than air. That is the reason we use that downward displacement of air to collect ammonia, right? हाँ, मेरा correct है? क्या बात है जी? Network problem. That's okay. So on the leaderboard we have Shreya, Spandan, Aditi, Shruti, Shreya, Sanvi, Nestler's reagent, Suchi, Gunjan, Anjali. Very good. Okay, the last question. The catalyst used in manufacturing ammonia is iron and molybdenum, molybdenum with iron oxide with K2O, iron oxide, K2O and Al2O3. Define photosynthesis. I know, wait. When, so it is basically, you know, leaves, they prepare their own food using carbon dioxide, water and chlorophyll. 3, 2, 1 and time's up. So basically what happens here is, see, so iron oxide, so actually they will just, you will get finely divided iron from iron oxide, and we are using molybdenum as a promoter, right? And sunlight, I didn't say that. Yes, of course, you can. So on the leaderboard we have Spandan, Shreya, Sanvi, Nestler's reagent, Suchi, Shreya, Aditi, Shruti. We have 2 Shrutis, Suchi, right? Suchi, Shreya, Aditi, Shruti, Anjali, Srilata. What is animalia? Are you people, you know, asking me biology related questions? What is animalia? I don't know. Yay, congratulations. Yo. No Yashasvi, so we are left with nitric acid and sulfuric acid. Tomorrow, yes, so I might come live. Surprise. Okay. No. Mendy on chemistry versus biology. I mean, who will teach me biology? Tell me. And what are also the Rutuja, do not forget to click on the bell icon so that you will know whenever I am live. Ting tong. That's okay. So, you know, do not forget to subscribe, share this video and like the session, and give lots of love to chemistry as well as elementary chemistry by Vedantu. So whoever is giving NTSE exam tomorrow, all the very best, and let me know how was the exam. If you can send me the question paper, it will be very useful for both of us. Thank you so much. What is it? Surprise, you know, whether I'll come live or not, that is it. Bye bye. Thank you so much for joining me and for staying for almost like 70 minutes. Aapki shaadi hogi, no? And if you want to take up the pro subscription, people, visit the link given in the description and at the pinned comment, or you can go to vdnt.in/ytpro as well, where you can attend. Once you take up the pro subscription, you can attend unlimited live classes with fun and high level quizzes. Yes, I can assure you about the fun part. And you can compete with the students throughout the world. I'm not talking about India, throughout the world. So interactive replays with live quizzes and leaderboards. So you can download, you will get the downloaded notes of the master teacher, handwritten notes. Here and there we will add some points of teachers, and there will be in-class doubt solving where there will be class teachers, master teachers who make sure that all of your doubts will be solved in the session. The test will be conducted regularly. You will be the assignments will be shared with you. So we'll make sure that, and we have different kinds of courses: long-term, micro course, crash course. So if you want to attend, if you want to revise any chapter, if you want to learn maybe the last chapter when I'm in the first chapter, so you can always enroll into micro courses or any crash courses which are absolutely free for you, which will be very helpful for not only the board exams, competitive exams as well. Oh wait, I know what are ciliantra. So they will have, this is how it looks, right? I know, so you know, I'll just write. What is this? So there will be some creature which looks like this, no? It will be attached, you know, it just gets stuck to the rocks and all that. What is that? Molluscans, ciliantra, and I don't know. No. Biology. I know phylums. No, I was talking about that species. What is that? मेंटी होगा जी, मेंटी होगा. Okay, Aniket. Sorry for that. थोड़ा सा. Okay then, hello people. I'll see you tomorrow. Till then, take care. Keep loving chemistry and please stay safe, stay happy. All the very best. Okay. Bye bye. Thank you, Rishit.